Guys and girls, it's know it time! Know it time!
When I taught you derivatives, I always go back to what we call the definition, which was limits. See, derivative really came from limits. So I want to revisit you on this idea of limits. If I ask you limits as theta approaches 0 of sine theta, what would your answer be? Before you can learn derivatives, you got to go back and relearn the basics, which is limits. 0? It is 0. Correct. Easy. But what if I decide to give you a bit more challenging? Limit theta approaches 0 of sine theta over theta. Ooh. A lot of you say, hey, Mr. No, it'll be 0 over 0. My life is easy. Just D and E. That's the possibility of you getting an A in my class. D and E with that answer. No. See, nope, we're close. See this, if I go limit, you say, well, that's 0 over 0, so that's D and E. Hey, can we use the squeeze theorem? So someone's thinking. Say, Mr. No, didn't you teach us about the squeeze theorem? So let's try the squeeze theorem, guys. It may work, I don't know yet. Sine theta, to do the squeeze theorem, we set up with my right limit and left limit. Go ahead, fill in the right limit and left limit of a sine graph. Easy. Imagine the sine graph in your head. 1 and -1. But the problem is, I have theta right here. So I'm going to divide everything by theta. Theta? Theta. So lim as theta approaches 0. But then a lot of you say, hey, that just gives you 1 over 0, which again still is D and E. Say, hey, Miss No, look. We just proved using theorems D and E. In this case, we have a special condition. This is called special limits. Special limits means you got to memorize it. So there's going to be 2 special limits you got to work with. These are special trig limits. Nope. Special trig limits. The first one states this. Lim as theta approaches 0 of sine theta over theta, which is what I did. But I want you to focus on this main thing. This number has to be exactly the same as this number right here. Has to be the exact same thing. Can't be any different. If those 2 conditions are met and it's a sine, then your special limit is known as 1. Bubble this. You're going to need to know this. They're going to ask you this a lot on exams in universities. The second one is a bit more challenging. Lim as theta approaches 0 of cos theta minus 1 over theta. See, if I just sub in 0, you would get 0 over 0. But in this case, your limit is going to be 0. Now, to prove this, there's actual proof that you won't learn until the end of June. It's called L'Hopital's rule. But for now, I can't teach you L'Hopital's rule. You're not ready for it yet. We're just going to keep it simple as that. So 2 special limits. Hi.
It's cos theta minus 1 over what?
Over theta. And the key thing I want you to notice is this. Theta has to be the exact same number. Okay? If they're different, it screws up. You can't do it. It was different. We have to modify it and show you how. I'm going to give you an example. Example. Lim. Theta approaches 0. Sine 3 theta over 3 theta. Okay. This is a typical example I can ask you. Because if you sub in 0 right away, you get 0 over 0, which can't be done. So we go back to my little rule. And you say, hey, look, it's the same. So it actually does equal to 1. Easy. Okay. So I'm going to say, hey, so that was easy. Give me something more challenging. I'm going to steal this question. It'll be a bit more challenging. Good luck. I got to find a super challenging question for you. Try this. Lim as x approaches 0 sine 7x over 4x. I'm going to pause it. Your hint is, I wanted to match this form. Problem is, if this is 7x, the bottom has to be 7x. The problem is there's a 4 on the bottom. So I walked around, I think I only saw Manat has the right answer for it. Manat, what did you multiply this by? So you multiply this by 4. You multiply this by 7. I'm not sure if this is right or wrong, but we're gonna analyze her work in 1 second. So here's what it is. See, the reason you're actually on the right track, Manat, but it's not quite correct. See, the reason why is, if I multiply this by 4 over 7, why can't the top number be anything you want it to be? See, if you multiply by 4 over 7, you get a totally different question. But what if I asked you to say, hey, what if I multiply by 1? Would you agree anything times 1 will give you the exact same equation? So I can multiply by 1. But the 1 doesn't really help me out, because I want the bottom to be a 7, because that's what the bottom to be. So let's rechange this 1 into a fraction.
Oh, you want to be 7?
What did you say? 7 over 7. Because 7 over 7 is 1. So if I multiply this by 7 over 7, I get a 1. But if I do this, watch what happens. This becomes sine 7x over 7 times 7 over 4x. Really, all I did was I swapped the two things around. Exact same thing, except I just made it into a format you can actually see. Oh, how, what, where, when, why? Where? So which part are we lost on? Nope, I multiplied by 1, agree? But I want this to be 7, because it has to cancel, because it has to match my form. So I turned this into 7 over 7, because 7 over 7 is still 1. Okay? So then, what I did was to make it so it's easier to see, I just swapped these two numbers around. Okay? So now this becomes 7 sine. So this becomes lim as x approaches 0 of this entire thing right here. And according to your limit rules, I can bring this, since this is just a simple number, to the front. Because it's just a simple number.
But how did you get 7x?
How did I get 7x? Okay, here's what I did. Would you agree this becomes sine 7x times 7 over 4x times 7? Which is the same thing as saying 7x times 4? Which is the same thing as saying potato. Okay. So now, this becomes 7 over 4 lim x approaches 0 sine 7x over 7x. Ta-da! I made my life a lot easier by multiplying by one simple number, and that number really is 1. You're allowed to multiply by 1 because multiplying by 1 doesn't change anything. This cancels out. Well, really, this becomes a 1. Because the limit of that is 1. So your answer really is 7 over 4. And that is how we deal with this. Try this on your own. I'm going to take this question straight from your book. Hi, you have a free quiz on first day back. Lim t approaches 0 sine 10t over t. Or we'll call it 3t. I'm going to pause it. The key is to multiply by this by 1. Because you can multiply by 1, but I want it to be in a format I can work with. So that becomes times 10 over 10. Which becomes lim as t approaches 0 sine 10t over 10t times 10 over 3. Well, my answer simply becomes 10 over 3. Ah, good question. Because what's this limit right here? Oh no, not 0. 1. Where you can't use this? Yes, I'm going to show you right now. I'm just trying to figure out some more challenging question from your book, because these questions may be too easy. Try this one. Lim x approaches 0 of x cotangent x. What's the answer to that? If you need a hint, the key is this. convert this into cos over sine. So this becomes x times cos x over sine x. That's the key right there. But if I were to sub in 0, you get 0 over 0, which is undefined still. So we know we have to do something else. I'll give you a few minutes to see if you can figure this out on your own. Is this x right here? This is a tricky move. And it's based on, say this x is a key. If you can figure out, sorry? Cosine squared x, no. The key is this x. If you can figure out where to put this x, you actually figure out your answer.
But there's no rule that has an x.
This goes back to a little trick that you should know. This is a fraction trick. If I have 2 over 3 over x, would you agree this really is 2x over 3? So if I give you this format, would you agree you can rewrite it as this format? So figure out, that's your hint. I can rewrite this as cos x over sine x over x. Agree? And look at this. Hey, there's a little trick again. Sine x over x is really just 1. So this becomes cos x over 1. And lim, as x approaches 0, of cos x, really cos of 0 is 1. Ta-da! Somebody say, Mr. How am I supposed to figure that out? That is the level where you have to function in college university, where you have to learn to work backwards and forwards. The trick is say, oh, once you see it, say, oh, that was easy. But without realizing how this works, a lot of people will say, how did you get x on the bottom? Well, that's really what, well, this x really came from this bottom right here. Okay? This x was from the bottom, now it's on top. Now, from limits, what we did next was I taught you derivatives. These are called trig derivatives. You have to memorize this. There's no way around this. There's going to be 6 you got to memorize. If I told you f of x really is x squared, a lot of you don't need to memorize. You just look at it and say, I know the answer is f prime x equals to 2x. That's easy. I agree with you. We don't need to memorize anything. It's just like common knowledge. But if I told you that f of x equals to sine x, then what's the derivative of sine x? These are special trig derivatives you're going to need to know. First one, d dx of sine x. The derivative of sine is actually cos x. d dx cos x. Here you go. So some say, hey, so derivative of cos is sine x. You're actually correct. Derivative of cos x is really negative sine x. d dx tan x secant squared x. So I'm going to call 1, 2, 3. The 4th, 5th, and 6th one are the minor ones because they're rarely used. But these are the big ones you need to burn in your head. 1, 2. You can't avoid them. The only way to do it is memorize it. 4. d dx of cosecant x. And this is where it gets confusing. Negative cosecant x cotangent x. Yep. Negative cosecant x times cotangent x. 5. d dx of secant x equals to secant x tan x. 6. d dx of cotangent x equals to negative cosecant squared x. 6 trig derivatives you got to memorize by heart. The first 3 will be used on a regular basis. The last 3 you will see once in a while, but you should know them. I'm going to give you one question, and that wraps it up for today. I'll start off easy. Fx equals to, I lied, I'll start off insane. Secant x over 1 plus tan x. Find the derivative of that. Go. See, this is a quotient rule because there's a fraction there. So we take the derivative first. The derivative first really is secant x. Is secant x tan x. Secant x tan x. Times the second, which is 1 plus tan x. Minus derivative of the second, which is secant squared x times secant x all over 1 plus tan x all squared. I'm going to pause it. Now, I'm just going to simplify a bit, and this becomes secant x tan x plus secant x tan squared x minus secant cube x. See what I did from beginning to end? If I look at this, I notice I can factor out a secant x. So let's factor out secant x. You don't have to factor out, so you can leave it like this, which is perfectly fine, and I will accept your answer the way it is. Okay. But if you want, you can factor out a secant x. So if I factor out secant x, it becomes secant x tan x plus tan squared x minus secant squared x all over 1 plus tan x all squared. That is how we deal with the product quotient rule using trig identities. And that is the rest of it for today. Your work. Lesson